Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 907. Please turn to it. Page 907. Today is our lesson number 129. Problem number 15. We are told that we have quantity x which is divisible by 3, we are told, and we are told that this quantity y is divisible by 5. The question is, which of the following must be divisible by 15? They use the word must, which means something that has to be true all the time. We are looking for quantity that must be true, that must be divisible by 15 all the time. That has to be divisible by 15. Let's look at first expression there. The first one, they tell us x times y. Let's talk about it. We are told that this quantity x is divisible by 3. They go on to tell us that y is divisible by 5. Well, if x is divisible by 3 and y is divisible by 5, then their product, of course, has to be divisible by 15. Their product has to be divisible by 15. That tells us the correct answer, whatever it is, must contain Roman numeral 1 in it. Let's look at the answer choices. A, B, C, D, E. A, B, C, D, E. Let's put it a little bit higher. What can we cross out? Correct answer, whatever it is, has to have 1 in it. We can cross out B. And that's about it. Everything else has 1 in it. Well, now what do? Well, very simple, very straightforward. Now, we plug in values for x and y such that x is divisible by 3 and y is divisible by 5. Plug in anything that you want. For example, plug in 9 for x, for example, and plug in 10 for y. 10 is divisible by 5, 9 is divisible by 3. But when you're using plugging in technique, and when you're putting in values for the variable, you have to be careful. You have to be smart about it. You have to use your brain a little bit. In other words, they say x is divisible by 3. Listen very carefully. They say x is divisible by 3. Don't plug in 15 for x. 15 is divisible by 3. But don't plug in something silly as 15. Why? Because the whole point of this problem is that we're looking for a unique number that is divisible by 3. Another unique number that's divisible by 5. Picking a number that is divisible by both 3 and 5 will ruin the whole thing, will defeat the purpose. We're trying to see here which of the following is divisible by 15. So if you plug in something that is divisible by 15, it ruins the whole thing. Don't plug in x here because x is divisible by both 3. Don't plug in 15 there because 15 will be divisible by both 3 and 5. Plug in something unique that brings out that feature that it is divisible by 3 only. Plug in 3, plug in 12, plug in 33, whatever you like. But at the same time, keep your numbers as small as possible. The smaller the number, the less calculation you will have to do. You understand? So that works. Let's look at second statement. Second statement tells us that the quantity is 3x plus 5y. 3 times x, which is 9, plus 5 times y, which is 10, and 9 times 3 is 27, plus 50, which is 77, and 77 is not divisible by 15. It's not divisible by 15. Because of the use of the word must, this expression has to be divisible by 15 all the time. And since we found one exception, 77 is an exception. If x happens to be 9 and y happens to be 10, the expression turns out to be 77, which we just found is not divisible by 15, which means the correct answer, whatever it is, cannot have 2 in it. What can we cross out? We can cross out answer choice E, and we can cross out answer choice C. The answer is either A or D. And my gut feeling tells me that the answer is not going to be A, because A is too simple an answer. For number 15, A is too simple, because anybody can see that if one number is divisible by 3 and the other number is divisible by 5, then of course their product is going to be divisible by 15. Big deal. There's got to be something more than that. So my gut feeling is that the answer is D. Let's look at D. Let's look at now third statement. In the third statement, they tell us that 5x plus 3y. 5x plus 3y. 5 times x, which will be 9, plus 3 times y, which is 10. So here we have 45 plus a 30, which gives us 75, and 75 is divisible by 15. 75 is divisible by 15. The answer is D. The answer is D. The third statement works, which means the correct answer, whatever it is, must also contain Roman numeral 3 in it, which rules out A. And we are left with D. Number 16. Problem number 16. Number 16. We're given a picture here. This we are told is y degree. This we are told is 115 degrees. And this we are told is z degrees. And the question simply is, how much is y plus z? How much is y plus z? Well, let's see what we can do. There are a couple of concepts that they're testing here. One concept is that a straight line always makes 180 degrees. If you have a straight line here, for example, that's a straight line right there. This line here is a straight line here. This is a straight line. Let's draw that straight line the way it is at the same angle. Here's a straight line, and we are told that this is y degrees. This is y degrees, which means the leftover, whatever it is, this leftover part has to be 180 minus y. It has to be 180 minus y, because the entire thing makes a semicircle. A straight line is a semicircle, which is made up of 180 degrees. A straight line always makes 180 degrees, which means this part right here that we see here is 180 minus y, because of the fact that this is y. Similarly, this part that we see here, this angle that we see here, since this is z, the inside part is 180 minus z. And finally, this angle that we see here, it is simply 180 minus 115. And what do we know about the sum of the angles in a triangle? Sum of the angles in a triangle always add up to also 180. So now we can add up all the three angles. 180 minus y, 180 minus y, plus 180 minus z, plus 180 minus 15. And it has to add up to 180. These three angles have to add up to 180. I know it's a weird looking equation, but these three quantities have to add up to 180. Let's do it. Let's put them in the horizontal way so that we can see it in a usual way. So we end up with 180 minus y plus 180 minus z plus 180 minus 15. I'm just going to write down the quantity. 180 minus 120 would have been 60. Therefore 180 minus 115 should be 65. And that quantity equals 180. All of these three angles here, this angle, this angle, and this angle, have to add up to 180. We see 180 here, we see 180 here, which means if we subtract 180 from both sides, we can get rid of this one of these 180. So let's do that. Subtract 180 from this side, and subtract 180 from this side. Subtract 65 from this side, and subtract 65 from this side. No, that's too early for that. Too early for that. So this drops out and this drops out, and here we end up with negative y plus 180 and a negative z plus 65 equals 0. 180 plus 65. How much is 180 plus 65? 180 plus 65 is 5, 14, carry 2, 245. So negative y and a negative z equals negative 245. I'm not going to show you that step here, but if you were to subtract 180 from this side and subtract 180 Subtract 180 from both sides and subtract 65 from both sides, so that this 180 ends up on the other side of the equation as a negative 180. This 65 will end up as a negative 65 on the other side, and this is the equation that we get. Negative y and negative z add up to negative 245. If you were to multiply the entire equation by negative 1, take this equation and multiply it by negative 1, and take, not this equation, rather this side of the equation, and multiply this side of the equation by negative 1, we can get rid of all the negatives. So now negative 1 times negative is positive, so we get positive y, and negative 1 times negative is negative 1 times negative z is positive z, so we get y plus z, which is exactly what we're looking for here. Y plus z equals 245. That's it. Y plus z equals 245. Next one. Number 17. We are done with this one. The sum of three consecutive odd integers is 111. But how do we express the sum of three consecutive odd integers? For example, if the first one is 3, since it doesn't, what we are about to say will apply equally even if there were three consecutive odd integers or three consecutive even integers. What happens is that here it happens that we have three consecutive odd integers. So if the first one is 3, the next one is going to be 5, the one after this is going to be 7. How do we express this algebraically? If we're going to represent 3 by n, the next one is going to be 3 plus 2, which is n plus 2. And this one is going to be our first 3 that we see there. This is going to be a 3 plus 4, because this one is 2 more than this guy, the middle guy, and this one is 2 more than the first guy. So this is just n plus 4. There we go. These are our three numbers, and we are told that when we add them up, we get 111. All we have to do now is to simplify this equation, and that's all there is. They're looking for, it says if n represents the least of the three integers, which it does, n represents the least of the three integers, because the one after that is n plus 2, and one after that is n plus 4. Which of the following equation represents the statement above? Let's find out, shall we? Simplify it. So we get an n here, an n here, and an n here. We get 3 n's. And then we have plus 2 and a plus 4. So plus 6 equals 111. There we go. This equation represents the statement that is given to us, which is that the sum of three consecutive odd integers happens to be 111. And that will be answer choice D. That's it. Answer is D. Next one, number 18. Number 18 is nasty, I'm warning you. Number 18 is nasty. And we still have number 19 and 20 to go on the next page, which are even more fun. Okay, number 18. We are given a picture here. It looks something like this. And this arc that is given to us is made up of 3 segments. Let's break it up into 3 segments. 1, 2, and 3. And then here is the B part, here is the B part, and here is the B part. And this is 2, 2, and 2. In other words, each of these segments here that I'm showing here from here to here, each of this segment is made up of B plus 2. This guy is B plus 2 from here to here. And this guy from here to here is B plus 2. The question is, how many B plus 2 do we have in the entire circle? Because they only show us the part of a circle. Let's read the problem, shall we? It says picture above shows part of the circle, of course, as we just figured out, whose circumference is 45. Ah, there we go now. Whose circumference is 45. Alright. If the arc length of 2, if the arcs of length 2 and B continue to alternate around the circle, around the entire circle, so that there are 18 of them, so that there are 18 arcs of each length. There are 18 of them. So here's the first one, B plus 1, B plus 1, B plus 1. They show us 3 of them, but there are 18 of them. Therefore, the length of this 18 of this arc would have to equal 45, because we have just been told that the length of the entire circle is 45. Of course, when one talks about when one is speaking of a circle, one does not use the term length, but that's what it is. The circumference of the whole circle is the distance around the circle, length of the circle, if you wish, if you will. And we have been told that it's 45. Therefore, and since whole circle is made up of 18 of these segments, we are told that the entire circle is made up of 18 pairs of b's and 2's. 18 times b plus 2 must be 45. Let's see what we can do here. So that gives us 18b plus 18 times 6, which is 36, and that equals 45. Subtract 36 from both sides, and we end up with 18b equals 9, which tells us that this b part that we see here is only half. This b that we see here, this part right here that we see here, equals half. That will come in quite handy, because the question that they're asking here is that what is the degree measure of each of the arcs of length b? Well, we know now the length of b is equals to 2, and we also know that the entire circle is made up of 45 units, whatever the units happens to be. Well, maybe it's 45 inches or 45 centimeters or 45 miles. We really don't care. If the entire circle happens to be 45 miles, then this segment from here to here is half a mile. Or if the entire circle is 45 inches, then this is half an inch. And we also know that the entire circle is made up of 360 degrees. So that makes our life easy. All we have to do is set it up as a proportion problem. 360 degrees is made up of 45 inches or 45 centimeters, whatever it is. We just have to find out how many degrees in half of it. Half a unit. Let's find out. We're done with this part. I need the room, so we're going to erase it. Set it up now as a proportion. So here is the degree, and here is the length. Length of the arc, if you will. The arc here will be just this part right here now. And on the top, when we put down 360 degrees, the length of the so-called arc actually is the whole circle. So how many degrees? How many degrees in the length of half a unit? That's all. Cross multiply it. Here we have 360. 360 times half. 360 times half must equal 45 times x. 45 times x. Half of 360 is 180, which means 45x equals 180. Divide both sides by 45. So we can get rid of this 45, and now our x degree that we're looking for here is simply 180 divided by 45. How much is 180 divided by 45? Well, how the hell do I know? I know 90 divided by 45 is 2. 90 divided by 45 is 2. And 180 is 2 times 90. Therefore, it must be 4. That's it. This x, this degree measure that they're looking for, is 4 degrees. The answer is A. The answer is A. Now, the $1,000,000 question is that, will you be able to do all this thing during the exam in the time that you have? That's where they separate the, I don't want to use a sexist expression, but that's where they separate the boys and the men. There is no such expressions as the boys and the women. There is no such thing. This is what I mean by sexist expression. But anyway, that's where they separate these people who are going to score really, really high and the people who are going to be mediocre. And that requires practice. The more problems you practice, the better you will get at doing the exam, taking the exam, because you'll be familiar with the concepts that appear in the exam. That's all it is. It's just a matter of practice. You understand? And the very fact that you're watching this particular video actually is a good sign, because this is actually exam number 9. A lot of the times I come across students, they buy this book and they just do like 2 or 3 per exams in the beginning, and that's it. That's not enough. Do all of the 10 exams. You understand? Anyway, I will see you tomorrow, okay? Bye now.